Hey guys, this is Mr. Beckstrom, and I wanted to do an example of a problem. I got a request for section 4.4. This is similar to number 21, and it's asking us to do a regression equation for natural log regression equation. So this is a pretty kind of complex, kind of lengthy problem here. So let's just kind of go through it here. It says the percentage of households with children that consist of two-parent families is shown in the table below. The first part says use a logarithmic regression on a graphing calculator to find the best fitting curve of the form y is equal to a plus b times the natural log of x, where x is equal to 0 corresponds to 1960. So 0 is 1960. That means 1970 would be 10 because it's 10 years later. 1980 would be 20. 1990 would be 30. 92 would be 32, so on and so forth. So you're going to go to your graphing calculator. I'm using the software here, the SmartView software, which should be if you're using a TI-83, TI-84, it has the same buttons here. And I go to Stat, Edit, and for my L1, I'm going to put in all the values for the years. Remember, you start with 10 because 0 is 1960, so 1970 would be 10 years later, all the way to 2000, which is 40 years after 1960, so that's your L1 list. And your L2 list, which is going to be your dependent variables, is just these values here: 86, 76, 74, 70, 69, 66, 66, 66. So just make sure those are all in your L1 and your L2. Remember, if for some reason you don't have your L1 or your L2 up there and you need to put it in, you can move the cursor up to one of those and you can insert it in there. So the insert is directly above your delete, so you hit the second key and then the delete, which is the insert, and then you can hit second and put L1 back in there, and that's right above number 1. So you hit second 1 and then enter, and that'll insert that L1 back in there. All right, so you've got all your L1s, your L2s. Now we've got to get that regression equation here. So the way we do that is we go to Stat, and all of our regression equations under Calculate. So far we've been using just this normal linear regression equation, which is the ax plus b, but they want us to use this natural log regression equation, which is the ln regression equation. It's number 9 down here. So you should have that if you're using the 83, 84 calculators. So hit enter. Yes, we want to use L1, we want to use L2, and because I've already done this problem, I know that we're eventually going to want to use the regression equation. So I'm going to save this to my Y1 equation. So instead of putting this manually in later, I can go ahead and tell it to store it in my Y1. So where it says store regression equation, I'm going to hit my vars key right here. I'm going to go over to Y variables and hit enter under function and hit enter under Y1. And what this does is it's going to take this equation and it's going to store it under my Y1 equations. Just like if I were going to Y equals and put this equation in Y1, when it figures out whatever this equation is, it's going to automatically store it in there for me and save me some time. And I'm going to hit calculate. And here's the equation. So notice that this form here matches up with that form here. So here's my A and here's my B. And so now I just have to type it in there and replace A with that A and B with that B, and just make sure the natural log of X is there. So that's what I'm going to do right now. Oops. Take those two dots off of there. So, and remember, they want me to round to 3 decimal places. So this is going to be off screen, but I'm just going to replace my A and B. Notice my B is negative, so it's going to end up being a minus there. So what it's going to look like is this. So when I type it in there, it's going to be A, which was 119.794 rounded. This is to the thousandth place, which is 3 decimal places, 794. And then it's plus, but since I have a negative b, I'm going to do a minus. And this is 14.486. And then I'm just going to put natural log, so ln. When you type in ln in my math lab, it automatically darkens that ln because it knows it's the natural log. And then I'm going to do open parentheses, just type in x, close parentheses, and that's it. Hit enter, and it should take this equation because it's in that form right now. So that's the regression equation for the natural log. All right. So for the second part, it says use, and just make sure that that matches up with that, which it does. This B matches up with that, which it does. I'm good. This R here is the linear correlation coefficient, which we're going to be discussing more in Chapter 8 and Chapter 10, but we don't need to worry about that one right now. And if yours doesn't have an R on it, don't worry about it. You can get to that by going to catalog, but you won't need it right now. All right. B says use your equation to predict the percentage of two-parent families in 2010. So now that I've stored this equation in my Y1, notice it automatically got stored there because I did that store equation field for Y1. So now all I've got to do is this. From my main screen, I just hit vars. I go to Y variables. Enter, I put the Y1 in there, so it pulls my Y1 equation, open parentheses. I want to evaluate that Y1 function at, they want to know, use your equation to predict the percentage of families in 2010. Well, 2010 is 50 years after 1960, right? So that's, my X is going to be 50. So I'm going to do 50. Right, because these are the years, so 2010 is 50 years after 1960. Enter, and it says round to the nearest whole number is needed, so that's just going to be 63. So 63% will be my answer for that one. All right. Now the next one, it says in what year will the percentage of two-parent family reach 50%. So this one's going to be a little bit trickier here. So what we're going to do is this time, remember, the percentage is going to be the Y variable there, right? And so notice that it's kind of getting lower and lower. So it's going to be sometime well after 2000. So we're going to have to kind of go far into the future. So where we're going to set this up is we're going to take the original equation here. So this is going to be 119.794 minus 14.486 times the natural log of X. And we're going to set that equal to our 50% because we're trying to find out how many years after 1960 are we going to reach that 50%. So this is how we're going to set that one up. If it was 40%, we put a 40 over there. Now we need to solve for X. So first we need to isolate X. So I'm going to subtract that 119.794 from both sides. So negative 14.486 times the natural log of X is equal to, and this is going to be 50 minus the 119.794, which is negative 69.794. All right, now I'm going to divide both sides by negative 14.486. So the natural log of X is equal to, this is negative 69.794 all over negative 14.486 0.486. Now, in order to get x by itself, we can take we can exponentiate both sides. That means exponentiate means we basically do e to both sides, and so we're going to these are going to become the exponents of e. So it's going to be e to that, and then e to that, and e to the natural log of x cancels everything else out except for x, so we'll get x over here is equal to, and now we have this whole thing here. So I'm just going to put that in my calculator. So this is going to be, these negatives will cancel out there, so I don't have to put those in my calculator. So this is going to be, so e is, where is E in my calculator? I think it's, my buttons are so small. So for here, it is, I think it's this one. Yeah. So E to the, and we'll do 69.794, 794 divided by 14.486. All right, and we get rounded to about 124 years. 124 years. So we're not going to reach 50% until 124 years after 1960. So it'll be 1960, that's our year 0, plus 124 years. So that's going to be, what is that, 2084? 2084. So this is our answer for that one. Okay, so in the year 2084, that's when we expect percentage of two-parent families to reach 50%. All right, the last thing it does is it says graph your equation and the data on the graphing calculator. Does this logarithmic model look like another model that we have used before? So hopefully you've read through the chapter and you have graphed some of these before. So let's go ahead and do that. So it's already in my y equals, so I'm just going to go to zoom. If I don't know how to graph it, I can either do a zoom standard or a zoom fit. Let's look at a zoom standard first, see what it looks like. And nothing's coming up on the zoom standard, so let's try a zoom fit. Zoom fit usually works a little bit better with these. And there, zoom fit works much better on this one. And as you can see, it kind of comes down from the top, and it's kind of coming down, and the x-axis here is going to be the horizontal asymptote, and it looks like the y-axis is going to be the vertical asymptote. So this is definitely the graph of an exponential or a logarithmic function. So that looks like quadratic or exponential function there. So that would be A. All right. Hopefully this helps. I know this is a lot of information to process at one time. If you have any questions about it, please let me know, and I hope you have a great rest of your week. Thanks.